Hello everyone, welcome back to CMME Made Easy, and I hope you all are doing very well. Before we begin, let me remind my dear students that the contents of this channel are only to supplement your knowledge, not to replace the regular online and offline classes in your institution. So please attend your classes and do not miss them. Also, if you like our contents, please subscribe to our YouTube channel, like the videos and share these videos with your friends, with your batchmates, with your juniors. Also, if you are a teacher, then with your students. Please follow our Facebook page and the link will be given in the description. In our last video, we discussed about normal distribution, normal curve, area under the normal curve and its relation with the standard deviation, etc. If you have already seen the video, it will be easier for you to understand today's topic. But if you have not, I will recommend all of you to go to my previous video, watch it, have a clear concept about normal distribution and then come back to this topic. So today we are going to talk about standard normal curve. First, we need to understand the importance of unit, because we can measure variables using different units, right? So for example, here I have given the height of a person measured was 5 feet 9 inch, which can be converted into inch as 69 inch. We know that 1 feet equal to 12 inch, so 5 feet 9 inches is 69 inch. When the height of the same person was measured, but this time it was measured using centimeter scale, then it was found the person was 176 centimeter tall. 176 centimeter is basically 1.76 meter. So as you can see, depending on which unit we are using, a feet or inch or centimeter or meter, we can have separate values: 5 foot 9 inch, 69 inch, 176 centimeter, 1.76 meter. Similarly, there can be other variables which can be measured using different units. For example, weight of a person can be measured using kilogram or pound. Temperature can be measured using centigrade or Fahrenheit or even Kelvin scales. So since there are different units for each variable, that is why the values can also be different. So whenever we take the measurement, if we use different units, we can have different values, even though the temperature, the height or weight of a person is actually same. It remains the same, right? We learned in our previous video that how a normal curve will appear, it depends on its mean and the standard deviation value. So the shape of a normal curve, which can be height or width, etc., depends on the mean and standard deviation of the observations. So when we measure a variable using different units, we may get normal curves of different appearances. So if we measure the height of a person using inch, then we can have a normal curve of a particular shape. If we measure the height of the same person using centimeter scale, then we can have another normal curve, but it may appear different. So what can we do to address this problem? To eliminate the effect produced by the choice of units of measurement, the data can be put in the unit free form or the data can be normalized. So this is called normalization of data. That means we can do something so that the unit becomes meaningless, right? So unit, it does not matter what unit or what scale we used for measuring the variable, it can be made unit free. Now, what are the steps to make any value unit free? The first step is to transform the original variable to normalized variable, is to calculate the mean and standard deviation. So this part we learned in our previous videos. If we have a number of observations, from that we can calculate the mean value and also the standard deviations, right? So this part we can do. Next is we have to normalize the data. The normalized values are then calculated by subtracting mean from the individual values and dividing by the standard deviation. These normalized values are called the Z values. So this is very important and I recommend all of you to remember this part, because you will come across a lot of time in your studies, in your researches, in your thesis, where you have to calculate the Z values or you have to mention Z values. So what is Z value? When we subtract the mean value from the observed value and divide it by the standard deviation. I will give you the example so that you understand. Anyway, so x is the value of individual observation, mu is the mean, and standard deviation is represented by the sigma. Okay, so suppose we have taken measurement from 100 subjects. So for this 100 subject, the mean value and the standard deviation can be calculated. There will be only one mean value and one standard deviation. Now each of these 100 observations can be subtracted from the mean, or reverse, the mean value can be subtracted from each of these 100 observations and then divided by the standard deviation. So that means for each value we shall get one z value, right? Here is an example. The mean body weight of 100 students was 50 plus minus 5 kg. This means 50 kg is the mean body weight and the 5 kg is the standard deviation. Whenever you get a figure like this, the mean value is this plus minus something. This plus minus value means the standard deviation value. So calculate the z value for the body weight of 65 kg. So as I mentioned, there are 100 students and maybe one of the student had a body weight of 65 kg. So I want to know what is the z value for that student whose body weight was 65 kg. So for individual observation we shall have individual z value. Here x, the given observation is 65, minus mu is 50 and dividing it by the standard deviation which is 5. So 65 minus 60 divided by 5 is 15 by 5 equal to 3. So the z value is 3. So in this example, this is how you calculate the z value, and the z value is 3. Okay. Next, what we can do is the distribution of z always follow normal distribution. So as I mentioned, if we use the 100 observations, suppose the body weight of 100 students, we can use it to prepare a frequency curve which can be a normal curve, provided that it is following the normal distribution. Or alternatively, we can convert the body weight of these 100 students into normalized value. So that means for each student, for each body weight, we can convert it into a z value using this previous formula, this one we learned earlier. Now using this 100 z values, because we had 100 observations and from each observation we can make, or we can calculate one z value. So that means now we have 100 z values. So using this 100 z values, if we make another frequency curve, it will always be a normal curve. Now this one is not called normal curve, this one is called standard normal curve. It is written here because we have standardized the value, then we have prepared with the normal curve from the standardized value. So this is why this is known as standard normal curve. These z values that we have calculated is also known as standard normal variate or relative deviate or critical ratio. So if you ever come across these terminologies, standard normal variate, relative deviate or critical ratio, you understand that we are talking about z values. So this part we already said, if we replace all the observations of normal curve with a z score, so rather than using the body weight itself, we are using the z score for the body weight, then it becomes standard normal curve. Now what are the characteristics of a standard normal curve? It is smooth and bell shaped, perfectly symmetrical. This part is exactly same as the normal curve. Okay, it touches the baseline. Remember that standard normal curve touches the baseline. Mean, median and mode all coincide, which is also a characteristic of normal curve. Mean value is 0. Also we can say mean or median or mode, all values are 0. Standard deviation is 1. Variance is 1 because variance is square of standard deviation. So square of 1 is always 1. And area under the curve is 1. By 1 we mean 100%. So these are the characteristics. Often students are given short notes on standard normal curve. So you have to write the characteristics. If you write all these points, it will be correct. Now area under the curve is almost the same as the normal curve. So if we look at the mean value and then one z value on either side of the mean value, it will cover about 68%. So this is approximately, right? Similarly, two z values on either side of the mean value will cover about 95%, and three z values on either side of the mean value will cover about 99.7% of observations. So it looks somewhat like this, almost similar to the normal curve. So this is the midline, the mean value, which is 0. Remember, this minus 1, 2, 3 are the z values, so we can have positive. So okay, let me clarify this part. Here, look at this. This is the mean value that we are subtracting from the given observation. If the observation value is more than the mean value, this z value will be positive, right? Sometimes what happens, we can have values which are lower than the or less than the mean value. So in that case, this numerator will be negative and the z score will be negative. So that means we can have positive z score as well as negative z score. Both are possible. So on the left hand side we have the negative z scores, and on the right hand side we have the positive z scores. So from plus 1 to minus 1 z score we have about 68.2% of observation, this part. This is plus 2 to minus 2, which is a little bit more than 95% actually, and plus 3 to minus 3 is 99.7%. So this to this part, this wide range, a little bit of the population remains beyond the plus 3 standard deviation and minus 3 standard deviation. Now let us look at few examples to understand how we can use standard normal curve. The first example says distribution of score has a mean of 18 and standard deviation of 5. Determine the proportion of population having score less than 6. So probably some kind of scoring was done. We don't know what score this is, but let us assume that the mean score was 18 and the standard deviation was 5. Now that means a lot of people will have score less than 18 and many of them will have score more than 18. Okay, now many of these people will also have score less than 6. We need to know that what proportion of people in this given population had score less than 6. So for that, first we need to calculate the z value for the score 6, because we are concerned about score 6. So z value is observation minus mean divided by standard deviation. We have learned this, which comes out to be minus 2.4. Right? As I mentioned, z score can be positive as well as negative. So in this given curve, this is the mean value 0, minus 1z, minus 2z, this is minus 3. So minus 2.4 will lie somewhere here on this curve. Okay, so this is basically the position of the score 6, because the z value of score 6 is minus 2.4. We need to know how many people have score less than 6. So that means this area of the curve on the left hand side of minus 2.4 z score is the people who had score of 6 or less than 6. That is our question. Alright. Now we have to look at the z table. It is also known as standard normal distribution table or z table, and we can see z score of minus 2.4 corresponds to the value of 0.00820. So this is the proportion of people who had score less than 6. If we multiply it with 100, we get 0.82% population having score less than 6. So that means this area is actually less than 1%. It is 0.82% of the total area of the curve, and this area represent the people who had score less than 6, because 6, the z score for 6 is minus 2.4. This is the demarcation line for z minus 2.4. Now you can ask, where did I get this value, or how did I get this value? For that we need to understand what is known as standard normal distribution table or z table. It looks somewhat like this, and this looks very scary. Lot of numbers are given, but luckily we do not have to remember or memorize a single unit here or single digit here. Now, as I mentioned earlier, we can have positive z-score as well as negative z-scores, and because of that we have positive and negative z-score tables separately. Alright, now remember, for any z-score, this proportion which are given here represent the part of the curve on the left side of the particular z value. So look at the table here. In our example, we had z-score of minus 2.4. So this is the minus or negative z-score table. So we have to look at this. Now let me tell you, the z-score we are given here is minus 2.4. So this is the minus 2.4 row. What are the other values in the row? Now if you look at the column heading, these are the values for the second place decimal in the z-score. Since we have 2.4 in our example, which can be also mentioned as 2.40, that means the second decimal can be 0. So we have to look at the second decimal here. So that is why we shall be taking this column, because the second decimal is 0. If we had 2.41, in that case we had to take this column, right? In case of 2.42, we had to take this column. So depending on the second decimal, we have to decide which column we shall take, and depending on the first decimal, that is 0.4, we can decide from this column. So we have the value of 2.4 and the second decimal is 0, so we are taking this column. That is why in our example the value corresponding to minus 2.4 z value is 0.00820. that is what we mentioned here. That means 0.82% of the pupil lie on the left hand side of the z-score, given z-score. So that is my answer. So less than 1%, that is 0.82% people have score of less than 6. This is another graphical example. The demarcation line is at minus 1 z value, right? So if you look at the z table, negative z table, for z value of minus 1, and we have no second or third or fourth decimal here, we have 0 as the first decimal, so that is why looking at this first column. So z of minus 1 corresponds to 0.15866, or we can say 15.866%. So graphically speaking, 15.866% will have value less than, or we can say this proportion of people will be on the left side of the minus 1 z-score. Rest of the people, that is 84.134% of the people, will be on the right hand side of the demarcation line of z minus 1. That is how you interpret the z-score. So whatever values we have, that is on the left hand side of the given z-score. Alright, coming to the example 2, which is a multiple choice question from All India 2005 entrance exam. Very old question, but if you have clear concept, then you can answer any kind of question like this. So the PEFR of a group of 11-year-old girls follow normal distribution, which is given. Mean value is 300 liter per minute and standard deviation is 20 liter per minute. We have to find out which of these 4 statements is correct. So about 95% of the girls have PEFR between 260 and 340 liter per minute. The girls have healthy lungs. This is definitely a wrong answer, because from this data it is not possible to say whether the girls have healthy lungs or not. Rest of the options can be confusing, and maybe one of the answer is among these 3 options, A, C and D. About 5% of girls have PEFR less than 260 liter per minute, and all the PEFR must be less than 340 liter per minute. Now in these options we have certain values, 260, 340, 260, 340, right? So these 2 values, 260 and 340. We have been given the mean value is 300 and standard deviation of 20. For this, first we have to calculate the z-score for the value 260 as well as for the value 340. So mean is 300, standard deviation is 20. The two observations which have been given is 260 and 340. So the Z1 for 260 is -2, Z2 for 340 is +2. So as you can see, so 260 is 340 is basically 2 Z value on either side of the mean. And we learned earlier here, let me show you, that 2 Z values on either side of the mean covers almost 95%, a little bit above the 95% of observations. So that is why you can say this first option, about 95% of girls are PFR between 260 and 340 liter per minute, is the correct answer. Because 260 and 340 basically represents the +2 and -2 Z values. That means 2 Z values on either side of the mean value. So that is why this is the right answer. Let us look at the example number 3, which is the last example for today's video. So in a certain population, mean height is 66 inch, standard deviation is 2 inch. So these two information have been given. Mean 66, standard deviation 2. What proportion of individuals whose height will be more than 70 inch, less than 60 inch and in between 64 and 60 inch? So that means there are 4 values given, 70, 60, 64 and 68, and we need to find out the Z value for individual observation. So first is 70 inch. So 70 inch, if we look at the Z value is +2. Now we need to know how many people will have height more than 70 inch. That means on the right side of the particular given Z score. Now let us go back to the table here. For two standard deviation, for Z value of 2, the corresponding value is 0.97725. So that means this proportion of the area is on the left side of the curve. So if we have a line here in the 2Z plus 2Z position, the left part will be 97.725%. We need to know how many of the people have more than 70 inch height. So 70 inch, more than 70 inch is basically more than +2 Z value. So we are bothered about the right part of the curve. That means the portion of the curve which is on the right side of the given Z value. So on the left part it is about 97.225%. I'm sorry, 97.725%. So the rest of the part is on the right hand side. So we can subtract it and it is about 2.275%. So that is why you can say that proportion of people with height more than 70 inch is 2.275, because always remember the values which are given here are on the left side of the given Z score. Alright, if we subtract it from 1, because these are given in fraction, that will give the portion of the curve or area of the curve which is on the right side of the given Z score. So that is what we have done here. 1 minus 0.97725 is 0.02275, which is basically 2.275%. Now second question was less than 60 inch. So less than 60 inch means on the left hand side of the Z minus 3 value, which is very easy to determine because we can look at this part, this one. So 0.00135, or we can say 0.135% of the people have height less than 16. So 0.135%. And in between 64 and 68. 64 and 68 basically are Z score of -1 and +1. So we want to know how many of the people will have value 1 Z value on either side of the mean. Here we learned earlier that about 68% of the observation lie within the 1 Z value on either side of the mean. So if we look at this curve, So this is -1, this is +1, and this area, this much, is about 68.2%. So approximately 68% or 68.2% of the people will have height in between 64 inch and 68 inch. So that is our answer. So I hope the concept is clear. For any given value, we can calculate the z-score. It can be a positive z-score or a negative z-score. Then we have to refer to this table. This is known as z-table. And these values given here are the proportion of the area of the curve which is on the left side of the given z value. If we want to know what is the proportion of the curve on the right hand side, then we have to subtract this value from 1, and from that we can say how many people or what proportion of population belong to either this part or this part of this curve. So with this we conclude today's session. If you like the video, please subscribe to our channel and share this video with your batchmates, juniors and friends. We also have our Facebook page. The link is given in the description, and you can also follow our Facebook page. Thank you, take care, and we shall see you in our next video.